So what I did with you, I'm just gonna do it over in the recording for Amy's sake. You just forget Amy's still in class, and
Yeah,
she's watched all the recordings. So technically she'll still be here, but she's just not here physically.
she inspired.
Yeah. Because I do private art math sessions with her as well. So yeah, shout out to you, Amy. I just gonna go over this one more time. So this is I'm just gonna go over the main trigonometric identities you need to know. I'm not sure why my screen not moving. 1 second. Hmm. Okay, screen moving now. Nice. So what are the main identities you need to know? What is the main one? Main identity,
Is cos squared theta plus sin squared theta equals
right? Cos squared theta plus sine squared theta is equal to 1. That's the main one. And from that, we could say cos squared theta is equal to,
1 minus sin squared theta,
and sine squared theta would be equal to,
1 minus cos squared theta.
awesome. Now, there's also something you need to know. When you're dealing with trigonometric proofs, um, you will have to use, see what was again? Catalana, wake up. Um, difference of two squares, right? You'd have to use difference of two squares. So 1 minus sine squared theta and 1 minus cos squared theta, those are examples of difference of two squares. Can you tell me how they are examples of it? 1 minus sine squared theta. Remember, what is difference of two squares? Do you recall? Difference of two squares.
Is mm, be exact, like how to explain.
A squared minus b squared is equal to,
This is mean, by the film, a squared minus b squared is equal to a minus b squared, a minus b
a
plus b.
minus b by a plus b, a minus b by a plus b.
Yeah,
You'd be correct. Now, when we're looking at 1 minus sine squared theta, and 1 squared is the same thing as 1,
yeah,
and then sine squared theta means sine theta squared.
yeah.
So what come like A and what come like B?
Is the one squared
A is 1 and B is,
and b is sine theta squared.
no, not sine theta squared. Watch. A, A squared. So we have 1 squared, so A is 1. And then we have B squared, so sine theta squared. So B is sine theta. So how could I write 1 minus sine squared theta then? 1 minus sine squared theta, how could I write it using difference of two squares?
A minus b squared
Yeah, but where's A?
is 1
Minus
minus sine squared sine
sine theta, because sine theta is B, right? So 1 minus sine theta by,
by 1 minus 1 plus sine
yep, right. And what is 1 minus cos squared theta? Make a wild guess.
cos squared theta is 1 minus cos theta by 1 plus cos theta.
1 minus cos theta by 1 plus cos theta. That's what you say?
just now I'm on the phone, but what I know phone, what a package or something outside.
Okay, no problem.
Mm.
All right, Nicholas, are you back? Let me know if you're back.
Yeah,
All right, cool. So let me continue. So we went over the main identity. In almost all the questions, you have to use this. The other thing you'd have to know is difference of two squares, right? The other main thing you'll need to know is how to convert between fractions and multiplication and division. So let me give you an example of what I'm talking about. So you need to know this. So Amy, if you're looking at this, yeah, this is the main identity you need to know. There are also some other identities like tan, but I think we should know that. Um, Nicholas, you could just tell everybody fast what tan theta is equal to,
tan theta is sin theta over cos theta.
right? What would tan squared theta be?
Square theta is around
Think about
sine
it. Think about it in a common sense manner. If tan theta is equal to sine theta over cos theta, what do you think tan squared theta will be? What over what?
sine square theta over cos.
Yes. That's it. So just be aware of that. So if we had tan to the power of 5 theta, that will be equal to what?
Sine to the power of 5 theta cos to the power of 5
Yes. Um, sec theta is equal to what again? 1 over,
is 1 over cos
and cosec theta is equal to,
1 over sine.
right? So those are the main things you need to know. You also need to know how to convert fraction form to multiplication or division. Let me explain. If you had 1 over 4 all over 1 over 7, that is the same thing as a quarter, a quarter. What sign to put in the middle here? That's a quarter what?
Is
Listen?
divided
Right. So we have a quarter divided by 1 over 7. So how are we going to write that in the next line? What are we
you
going to write
could
in the next line?
you could indeed find or find the LCM.
No, you're not finding the LCM. You only find the LCM when you're dealing with addition and subtraction.
Right, well I would indeed the fractions and it would be 4 by 7.
You would invert which fraction? The 1 over 4, the 1 over 7.
1 over 4
No. This goes back to standard 5 maths. When you have two things being divided and you want to change it to multiplication, you would flip the term in denominator. So I would flip that 1 over 7 to 7 over 1. That's what I would do. Let me give you an example. If I had 2 over 4, doesn't that mean 2 divided by 4?
yeah,
So would I flip the 2 and say a half multiply by 4? That'll be 4 over 2. Is 4 over 2 the same thing as 2 over 4? Tama?
half
No, that'll be 2. 2 over 4 is a half. Half is not equal to 2. Watch. If I want to get back 2 over 4, that would be 2 multiplied by what?
by 1 over 4
Right. And you'll get back the 2 over 4 if you multiply that ends. 2 by 1 is 2 over 4. Don't know if you're okay with that.
yeah,
All right. So you just need to know this. Because sometimes you go see something like sine theta all over cos theta all over sine squared theta plus cos squared theta all over sine squared theta. You're gonna see things that look like this. How are we going to interpret this? Tell me, how are we gonna interpret this?
Gotta use the identities.
But before the identities, how are we gonna write that? How are we
Um,
gonna interpret that?
Sine theta over cos theta divided by you're simplifying the whole thing to
So sine theta over cos theta divided by,
sine squared theta plus cos squared theta over sine.
and now we could possibly look to simplify, right? On the screen. You seeing the screen moving or it's stick for you?
I see an
Are you seeing it moving? Okay. For some reason I don't see this moving. But that's okay. Once you've seen it moving. Actually, let me see if I can fix oh no, weird.
sound balloon.
Hmm. Yeah, I haven't seen it moving at all. Shit. Yeah, let me know if you've seen it moving.
Yeah,
All right, so now we could actually simplify. But wait. I say in sharpness. But we had to convert this division too.
multiplication.
Right. So that'll be sine theta over cos theta multiplied by what?
Sine squared theta over sine squared theta plus cos squared theta.
Right. Now we could actually simplify, right? So, um, you see anything we could simplify there? Can we do this? Can we cancel off sine squared theta with sine squared theta?
Um,
Yes or no? Can,
I don't think so.
is it?
I don't think so.
You can't because you have addition in the denominator. Anytime you add in two terms, you can't cancel off anything. Yeah. Right? So you can't do that. Is there any identities we could use to possibly simplify?
Um, Sine squared theta plus cos squared theta is equal to 1.
Right? So you say that this whole thing is one. You say that whole thing is one. So you're gonna put sine theta by sine squared theta, which is sine cubed theta, all over cos theta by one, which is cos theta. And that's it. You can't really simplify that anymore. Right? So yeah, those are the basics you need to know. So let me just read through the hints one more time before we delve fully into the trig proofs. So if you see sec theta, cosec theta, or tan theta, convert them in terms of sine theta and cos theta immediately. Find the LCM. 3. Look out for difference of two squares. We went through that. Number 4. Make sure you know your identity that cos squared theta plus sine squared theta is 1. You need to be able to convert fractions to division and multiplication. And lastly, look how you're trying to prove. Biggest hint. So let me start. Right. Right, so Nicholas, let me do this question here. So is everything in terms of sine and cos?
Um,
You seen any
yeah,
tan? Nah, you don't see any tan. That's good. So we could proceed to do what now?
could use the identity terms.
Nah, you have to find what I have
Um,
two fractions and I'm minusing.
or LCM.
Yes, you have to find the LCM. So what would be my common denominator?
1 minus cos theta.
Just one minus cos theta.
1 minus cos theta by 1 plus cos theta.
Right. One minus cos theta by one plus cos theta. Right? So 1 minus cos theta into this could be what?
Um, minus cos theta.
So if you divide 1 minus cos theta by this, the 1 minus cos theta will cancel off and it will leave you with what on top?
We'll leave it on top.
So watch this is what I mean. 1 minus cos theta by 1 plus cos theta all over 1 minus cos theta. These two will cancel off and it will leave you with what?
We'll leave it 1 plus cos theta.
And that 1 plus cos theta will multiply by the
Sine theta.
right. That's it. That's it right there. So then I would write sine theta by 1 plus cos theta. How about the next one?
Minus sine theta by 1 minus cos theta.
Nice. And I want you to remind me, this in the bottom, that's an example of what?
Is
Difference of two squares. Well, we know 1 minus cos theta by 1 plus cos theta will work out to be.
that is 1 minus cos theta.
Right. And what we know 1 minus cos squared theta is again?
Sine squared.
Yes, we know that 1 minus cos squared theta is sine squared theta. Yes. What happened there?
Sine
Yeah, I can see the screen now.
yeah.
And now we simplify on top. To simplify on top, how am I going to do that?
You have to expand it.
Yes.
Expand it.
So that we expand. Sine theta by 1 is?
Sine theta
So just keep going down the line. So sine theta,
plus sine theta plus theta
right?
minus sine theta plus sine theta plus theta.
Now we need to simplify. Yeah, tell me what to do next.
Sine theta, the start minus the sine theta in the middle.
Right. Those two would cancel off, right?
Yeah,
And so with sine theta cos theta plus sine theta cos theta again.
two sine theta plus
How much?
2 sine theta plus theta.
Right. And the denominator, what we know the denominator will work out to?
That is sine squared theta.
Right. See anything that can cancel off?
Yeah, the sine squared theta and the sine squared.
The sine squared theta and the sine theta, I mean.
Yeah,
So sine squared theta, what that means sine theta by sine theta. And we have a sine theta on top. So it will leave how much sine theta in the bottom? 1. So that'll be sine to what power?
sine to the power of
1. Which is just sine theta. So we're going to cancel off the sine theta. And let's go the number 2 will change to 1. So what's my final answer then?
is 2 cos theta over sine theta.
Right. 2 cos theta. Yeah. That's it. And that's your proof. I feel about this question.
It was easy compared to what I used to get in class.
Well, don't worry. Things will level up just now. Hmm. So copy down this quickly, and then we'll move on to some harder questions. and they itching for the harder ones. As soon as you have that copy done, let me know.
All right.
See the next question. The next question, real easy, is the same thing. Why is it the same thing? Oh no, it's not. It's a plus in the middle. So you should be able to do that like really, really fast if I give you it.
Yeah, done.
All right, nice. I want you to do this question in 5 minutes.
All right.
5 minutes. Or less. I think you could do it in less. Start. And you're trying to prove that that is equal to 2 over sine theta. Oh, and when you finish your proof question, I have two things you could do. You could either draw a little square to prove that you got what they wanted you to get. So in this case, they wanted us to prove that the left-hand side was equal to the right-hand side. So you
Yeah.
put up a square, or you could write q dot e dot d. Both of them mean that you solve the proof. Right, so C. Yeah, Nicholas, sorry about that. The internet's getting stupid. You hear me?
Yeah.
Okay, cool. Let me share back real quick. Yeah, this is a question. Yeah, Nicholas again, Drew.
Yeah, almost.
Nice.
Using final answer. I guess.
Final answer is 2 over sine theta. That's after the equal sign.
So, yeah.
All right. Yeah, nice. Good to go there. Safe to say, this too easy for you. Also too easy. See if you can do this one. And if you can't do it, we will do it together. So try
Right.
to prove that sine squared theta over tan squared theta minus sine squared theta is equal to 2 cos squared theta minus 1. Should I teach in class? So in this question, what's the first thing you're going to do? Come on, Nicholas, what's the first thing you have to do before proceeding forward?
But I use the um tan theta, the denominator, and turn it into sine squared theta over cos squared theta.
Yes. You know, if you're getting through that one, sine squared theta over the tan squared theta. Hmm.
Um, yeah, I think so.
Okay. I'll give you um 3 more minutes. Okay, let me check what you do there. All right, see if you change tan squared theta to sine squared theta over cos squared theta, then you change it to division, right? Then you change that to multiplication. One thing, if you're doing that, try to use some brackets. Try to use some brackets to separate it. So you see that sine squared theta divided by sine squared theta over cos squared theta. I probably recommend put brackets to that. Yeah. Put that in brackets. So the sine squared theta and the sine squared theta will cancel off. So you get cos squared theta minus sine squared theta, right? Then sine squared theta is 1 minus cos squared theta, right? You get an up with minus 1 plus cos squared theta, 2 cos squared theta minus 1. Excellent. Nice. Oh boy, even I didn't put brackets. What the hell? Let me put brackets now.
I added two brackets in the first part there, but first. Let's leave it out here.
Oof. So let me explain this question. So as the hints would have said, anytime you see tan theta, convert it in terms of sine and cos. So I would have converted tan squared theta to sine squared theta over cos squared theta, right? I write back the minus sine squared theta, and I continue from there. So sine squared theta over sine squared over cos squared theta, that's really what? Tell me, Nicholas. This is really what?
That is sine squared theta multiplied by cos squared theta over sine squared theta.
Right, you skip a little step. It is really sine squared theta divided by sine squared theta over cos squared theta.
Well, the
And if you change the division to multiplication, you have to invert the term after. So you have to flip the sine squared theta over cos squared theta. When you do that, you'll end up with this situation, and the sine squared theta could cancel off with the sine squared theta. So the only thing you're going to end up with inside here is cos squared theta. So you're going to have cos squared theta minus sine squared theta. Now we're trying to get 2 cos squared theta minus 1. Nicholas, in what we are trying to get, are you seeing any sine terms?
Ah,
No. So what we have to do is replace sine squared theta for something in terms of cos theta. So we know that cos squared theta plus sine squared theta is equal to 1. And I could make sine squared theta the subject. So sine squared theta is equal to 1 minus cos squared theta. So I replace the sine squared theta for that. And notice I put brackets. Brackets is very important. We had to put brackets because this whole term represents sine squared theta. Right? Then we expand. You're going to end up with cos squared theta minus 1 plus cos squared theta. The cos squared theta plus the cos squared theta is 2 cos squared theta. And that's what we give the answer. Nicholas, go with this question, right?
yeah.
Right. You want to try this question on your own? I will help.
Um,
Things getting tough now. This is where things get a little tricky.
yeah.
Yeah, let me
Um,
do it. Let me know.
we do it on here as an example.
Okay. You see how long the working is?
Yeah.
Um, all right. So the steps still hold. Um, so I'm gonna change that tan square theta to what?
Um, change it to sine squared theta over cos squared
Right. The denominator, I just leave that as 1 minus cos squared theta. What I look like I might have to change it to the 1 minus cos squared theta. But
sine squared theta.
let we not be too fast. Let me see how the question going first. All right. And then we're gonna minus that from 1 over cos squared theta. Okay. Normally, you would find LCM here, right? Because you have two different denominators. Isn't that true?
Yeah.
But the problem is, look at the term on top here. Yeah, in the first term there, in the numerator, you have 1 plus sine squared theta over cos squared theta. So you're adding two different terms that have different denominators. So this is a situation where you have to find the LCM here, then find the LCM for the whole thing. You understand? So here what we're gonna do. Let us find the LCM for 1 plus sine squared theta over cos squared theta. So let's just simplify this first. Some of you confused. I lose you anywhere?
Yeah.
Okay. The problem with this is we want to combine it to one whole term. So it doesn't confuse us later on. So I have 1 plus sine squared theta all over cos squared theta. And what would the LCM be for that?
Cos squared theta.
Right. Cos squared theta. What am I going to put here?
Um, sine squared theta.
But take your time. 1 into cos squared theta is cos squared theta. So cos squared theta by 1 is cos squared theta. This could be cos squared theta. You confused by that?
Nah,
Wait, you say sine squared theta though.
I
Hmm.
was gonna say sine squared theta plus cos squared theta.
Well, that's correct, but it just doesn't follow the order, right? And what next?
Then right after that is sine squared theta.
So let me ask you a question. What I look like it could simplify to?
Um, top could simplify to be one.
Yes. And we like what we see now.
Yeah.
Okay, so for this question, the first thing you had to do was combine these two terms together using LCM because they had different denominators. You always want to do that. Next thing, when we did it, we realized that we was getting cos squared theta plus sine squared theta, which is in fact 1. So we end up with 1 over cos squared theta. Awesome. So I have this little piece of work in here, right? So when I write back the question, what am I going to write? What do I know 1 plus sine squared theta over cos squared theta is 2 now? What do I equal to now?
1 over cos squared.
Okay, so when I write back the question, I'm going to write 1 over cos squared theta all over 1 minus cos squared theta. Again, I'm not going to assume, let me see how your question is treating us. I'm not going to replace our with sine squared theta just yet. Right, then I'm going to put a minus 1 over cos squared theta. What do you feel is the next step?
Um, but um,
Problems.
problem.
This is happening in the exam. With these kind
Yeah,
of questions. These kind of questions, you can get tired real fast. So, again, we following the same tips. This term over here, could we simplify that term? Is there anything I could do with that term to simplify it? I have 1 over cos squared theta all over 1 minus cos squared theta. What can I do with that term to simplify it?
with multiplier.
Yeah, I can multiply it. So, but before I do that, I had to write it in terms of division. So that'll be 1 over cos squared theta divided by what?
1 over cos divided by 1 over
Wait,
sine squared theta. No,
wait, take your time. That'll be 1 over cos squared theta. So this term here divided by 1 minus cos squared theta.
yeah,
It get troublesome faster.
yeah,
All right. Um, over here now, we're gonna change our division sign to a multiply sign, and that'll be 1 over what?
1 over 1 minus cos squared theta.
I think now is a safe place. We see that it not really gone. You see what I wanted to do, right? I wanted to make sure if I change it to sine squared theta, it wouldn't affect the problem. We end up in a stage here. If I write 1 minus cos squared theta, and I expand this, that will be cos squared theta minus cos to the 4 theta. That's not gonna help me. So to simplify things, I'm just gonna write sine squared theta. Tell me if you understand that,
Yeah,
right? And that work out to what?
that would be 1 over sine squared theta cos squared theta.
Yeah, we can't really do anything with that, right? Can't really do anything with that.
Yeah,
Okay, things looking simple now.
yeah, looking simple.
Right. Now you can find the LCM real easy now. What's the LCM?
Um, Cos squared theta sine squared theta.
Right. So the first term, let me do this term over here. Cos squared theta, sine squared theta, I could go into this how much times?
Into that cos 1 time.
One time and then 1 by 1 is? Right. The cos squared theta will leave a remainder of what?
Sine
Well,
squared.
well, it will go into it sine squared times. And then we go say sine squared theta by 1. So that'll be 1, sum of 1,
That'll be sine squared theta minus sine squared theta.
right? Because you have the minus sign here. So cos squared theta into this would be sine squared theta, and then sine squared theta by 1 is sine squared theta. So we're going to end up with 1 minus sine squared theta. And what do we know 1 minus sine squared theta is?
Is um cos square theta.
Yeah. You think that will help us?
Yeah,
And when we change that 1 minus sine squared theta to cos squared theta, what do you see happening?
you could cancel out the cos square theta.
Right. So we end up with, what we end up with.
It'll be 1 over sin square theta.
And is that what we wanted to prove?
Yeah,
Um, Once you follow these steps, you'll be fine. It's just plenty times, man, plenty times.
right up easy.
Right, so we'll copy that down. I have an alternative solution here. And this alternative solution look real simple. And
Yeah,
I would use a identity that's a little advanced. You ever see this identity before? 1 plus tan squared theta is equal to sec squared theta.
yeah, I see it before.
Yeah, that's the other solution. I'll explain that just now. But look at the working. Much more simpler compared to this.
Yeah,
Right, so yeah, you can copy this down. But you see, things get real complicated. Oh, you boy.
yeah.
Imagine Kiara just busting and she see this, she go leave.
You just have to shade that.
You able to read everything? I know it looking kind of small.
Yeah, I can see it.
Okay,
Get you.
all right, cool. So I think it's time for you to do a difficult question on your own. But before we proceed, let me look at the alternative solution. So there's another identity that probably wouldn't have seen because it's a bit more advanced. So this is another identity in addition to cos squared theta plus sine squared theta is equal to 1. And the identity is 1 plus tan squared theta is equal to sec squared theta. And well, we know that sec theta is 1 over cos. So sec squared theta will be 1 over cos squared theta. You understand?
Yeah.
Right. At the start of the question, and we have 1 plus tan squared theta.
Yeah.
So we could just replace that for 1 over cos squared theta. See if you catch.
Yeah, that's it.
So 1 plus tan squared theta, we know that is equal to sec squared theta. And sec squared theta is equal to 1 over cos squared theta. So we replace it. Remember, when we're working with these questions, we want everything in terms of sine and cos. We don't want sec, we don't want cosec, we don't want tan. Everything had to be in sine and cos. So I replace the 1 plus tan squared theta for that. And now I have 1 over cos squared theta divided by sine squared theta. You understand?
Yeah,
So I can write as 1 over cos squared theta multiplied by 1 over sine squared theta. Again, I'm gonna put brackets. So you're gonna put 1. So you're gonna put 1 over cos squared theta. 1 over cos squared theta sine squared theta minus 1 over cos squared theta. You find your LCM, right? And you get your answer. Pretty much, that's pretty much it. You understand?
yeah,
So much easier. So you can copy down this method too. Um, Amy, if you're looking at this, this is also another identity. Although it's not required at this level, you could do everything with sine squared theta plus cos squared theta is 1. This is also identity. If you remember it, it might make your life simpler at some points in time, like this. So you can copy this out, then I'll give you a question to do.
yeah, done.
Okay, great. Oh, um, hmm.
Yeah,
You think you're ready for a pass a question?
yeah, probably.
Try this question first.
Uh,
So 1 plus tan squared theta all over 1 minus cos squared theta. Wait, did we do that question already? I think we did not. Yeah, we did that question just now. Yeah, I don't know why this question is here. Um, Try this one. How things going?
I think I get through. Not too hard.
All right, nice. This one is an easy question, I feel. I feel it's
Yeah.
like
So be doing it.
look here, hello Kira.
Hi, Jane.
Kira, you might be a little lost, huh? A little lost. Um, might be a little.
I
Ooh,
haven't realized you recorded it already. That
yeah,
just from
no
the
problem.
conversation. Because I oversleep. Because I didn't have work today and I ended up sleeping late.
I understand. I also overslept. I literally roll off my bed and start the meeting. I say nothing big. I assume we all human. Yeah, Nicholas, that's it. Not real easy. Real easy question, right?
Yeah.
So just to explain, Kira, I wouldn't bother stressing you out. You go check back your recording. But if you catch on to anything, you go let me know.
Okay.
You know what tan theta is equal to?
No.
You watch back your recording. Tan
Okay.
theta is sine theta over cos theta. That is what tan theta is equal to.
Oh, okay.
So if tan theta is sine theta over cos theta, then tan squared theta will be equal to sine squared theta over cos squared theta. So in the topic we are doing right now, trigonometric proofs, your objective is to replace everything that don't look like sine and cos with sine and cos. So tan, we're not going to leave it as tan. We're going to write tan as sine squared theta over cos squared theta. Next thing you're going to do, well, the first thing you should have done, um, using the main identity, cos squared theta plus sine squared theta is equal to 1. That's the main identity you need to know. Cos squared theta, cos squared theta is equal to 1 minus sine squared theta. So I replaced the 1 minus sine squared theta for cos squared theta, and I replaced the tan squared theta for sine squared theta over cos squared theta. That is what I did. Right? So that's what start of the question. Next thing, over here, so Nicholas, over here, do I have the same denominator?
Um, ready?
Yeah,
Yes, sir.
over here.
Yeah.
No, the denominator over here is 1, and the other one is cos squared theta.
Oh, no. Yes, yeah.
So after you use your identities, what you have to do is you have to find LCM. If you have two terms and you add in two terms and they have different denominators, you add them or minus them by finding the LCM. So the LCM for the denominator is cos squared theta, right? So I probably should have put our work into the side. I'm gonna do that. So if I have 1 plus sine square theta over cos square theta. Kira, let me do this question. Where's the LCM here? Do you know by chance?
Would it just be cos square theta?
Yeah, it would just be cos square theta. Because 1 is just 1 over 1. And the LCM between 1 and cos square theta is just cos square theta. Right, 1x. So, tell me what
So
right?
it so you just put in the 1 plus the sine square theta.
No. Look at it, right? Wait. Imagine you had 1 over 1 plus a half. My LCM is 2, right?
Yeah.
Well, I'll put it away here. 1 into 2 is 2.
You put
1 is 2.
1 by 2 is 2, yeah.
All right, so 1 into cos square theta is cos square theta. Cos square theta by 1 is
Cos square theta.
right. What am I going to put here?
Sine square theta.
Right. Cool. And what is cos square theta plus sine square theta equal to? Do you recall? Cos square theta plus sine square theta is equal to?
1.
Yeah, that's equal to 1. So you're going to put 1 over cos square theta. So this whole thing here, I could replace it with 1 over cos square theta. Right? And you can see that. So we found the LCM for it. And then I replaced it. I replaced the cos square theta plus sine square theta for 1. Right? Awesome. In this line, Kira, let me explain what happened from this line to this line. So I have cos square theta all over 1 over cos square theta. So Kira, this over here is equal to cos square theta. What sign am I going to put in the middle? Add, divide, multiply, cos.
Divide.
Right. And if I go in from division to multiplication, how would I do that? What would I have to do with this term?
Triple.
Right, so I'm gonna end up with cos square theta multiplied by cos square theta over 1. And where's cos square theta by cos square theta?
It would just be 1.
No. What is x squared multiplied by x squared?
Mm,
Indices. When you have the same base and you multiplying powers, we do the powers.
you added
Right, so that'll be x to what power?
4.
Right, so cos square theta by cos square theta will be cos to the power what?
4.
Right, and that's your answer. That's what we wanted to prove. We wanted to prove that this whole thing here could be written as cos to the power of 4 theta. That's it. Yeah, right? So, hmm, this was the hardest question I ever see for trigonometric proofs. This is the hardest one I think I ever see. Um, Nicholas, you want to try it, or did you do it already in school? What do you say?
I think that do this one.
Well, see if you remember it. See if you remember it. Give it a try. I give you 10 minutes. Kieran, see if you can try that thing too. We cannot tough though because this is the hardest one, like I said, but try something. Just try something. Yeah, Nicholas, getting through. Try to make some progress. If you reach a point where you genuinely don't know what to do next, that's okay. But try something.
I reach 1 point from here to show it over.
Wait, sir.
I reach a point, but me and to show it over from here.
Send my picture. In this question, you have to actually introduce terms. Yeah,
Yes,
that's what makes it difficult. Right. See what you have here. So you change the sec theta for 1 over cos theta. Nice. You change the tan theta for sine theta over cos theta. Also nice. Um, you end up with 1. You found the LCM. You didn't really have, you don't have to find the LCM. Not easy. You just add them because they're the same denominator. Right? Nice. So you end up with 1 all over 1 plus sine theta over cos theta. You end up with 1 divided, right? 1 multiplied by cos theta over 1 plus sine theta. Right. So, Nicholas, you didn't do anything wrong, right? You didn't do anything wrong at all. Um, I want to see if I can guide you to get the answer. Look how we're trying to prove. Look how we're trying to prove, right? We're trying to prove. Wait, I want top.
1 minus sine theta over cos theta.
Right. And look at what we have right now. You have any way you could possibly get 1 minus sine theta from what we have right now? If you ask me, I would say no. Can't really do anything there.
Yeah,
So here we are to do. You have to introduce a term. I know it's all kind of abstract, but let me explain something. If I have 7 over, okay, um, if I have 1, Kira, and I could write 1 as, give me a number. 1. 1 is equal to what over what? Give my example. Two numbers divided by each other. Any two numbers.
Um, 3/3.
Right. That's 1. If I multiply the top by 2, and I multiply the bottom by 2 as well, and that will still be equal to 1.
Yeah.
So in this question, you actually have to multiply the top and bottom by a term. That's the catch in this question. So Nicholas, in the point you reach, right, it cannot do anything else. So, but you know that you need to get 1 minus sine theta on top. So that's the hint. In this question, when you reach that point, you have to multiply the top and the bottom by 1 minus sine theta. Because, I mean, you can't get 1 minus sine theta anywhere else. You have to introduce it into the question. But Nicholas, multiply the top and the bottom by 1 minus sine theta. See if you can get an answer. Nicholas, say, Emma, multiply the top
okay.
and the bottom by 1 minus sine theta. See if that helps.
Alright.
Shakira, what's good? What's good? Can I hear and Kira? Um, give me 5 minutes, guys. I'm coming back. In the meantime, Nicola, see if you can figure out this question.
Alright.
All right, I'm back. Nicholas, did you get the answer?
Yes, Anil.
Right. Let me see. Right, so you multiply by the 1 minus sine theta on both top and bottom. You recognize that it was difference of two squares, and that will give you cos square theta. The cos theta on top will cancel off with that. Nice. Yeah. You understand why this is one of the harder questions? Because I mean, how much people go and really think to multiply by 1 minus sine theta on the top and bottom?
Yeah,
Yeah. But how else you go get? How else you
uh,
go get? That's the thing. How else you gonna get 1 minus sine theta? So I will correct this question, and that'll be it. I'll give all you some homework, but we're basically done with trigonometric proofs. All you just need more practice, and all you should be good to go. Next
fine.
class, we're gonna start double angle identities, or compound angle formula, and then double angle identities. And that's it. So that's it for trigonometry. We could
Um,
start past paper questions. We could just I wanted trigonometry is something that's like I rank plenty marks. So I will dedicate a session to doing a trigonometric revision session. After trigonometry, I want to start calculus, which is differentiation and integration. I surely go benefit from that. And Nicholas, differentiation and integration.
I
Right.
know I lost.
Whew. So yeah, let me explain this question. Would you prefer me write it back on the board or just use what I have written one time? I'm ask Kara. Kara, would you prefer me write it back or just reference what is on the board one time?
You could just reference one the board.
Okay. So Kara, in these trigonometric proof questions, you cannot have sec theta, cosec theta, or tan theta. What's the only two things you should have?
Um, one and one of them.
What?
I'm not sure if you know what I mean.
We only allowed to have what trigonometric identities you're allowed to have? Like cosine, tangent, sine,
Cosine,
cosine and cosine and
tangent.
no. When you're doing trigonometric proofs, you're only supposed to have sine theta and cos theta only.
Why though?
Because sine theta and cos theta, those are the elementary trigonometric functions, meaning that you could represent all other trigonometric functions using sine and cos. Let me give you an example. If I want to write tan theta, tan theta is is actually just sine theta over cos theta, you know. Tan, th-
Mm.
tan theta is not something new. It's just a combination of sine theta and cos theta. Like we look at sec theta, secant theta. That is 1 over cos theta. Is that something new or does that have sine and cos in it?
It has cousin.
Right. And if we look at cosec theta, if sec theta is 1 over cos theta, what do you think cosec theta is? 1 over what?
Sine theta.
So let me ask you a question. All these things have one thing in common. All of them, they are not something new. They are just combinations or different variations of sine theta and cos theta. So that is why we're writing everything in terms of sine and cos, because those are the primary trigonometric functions. Understand? You understand that? Like all like tan
Yeah.
theta, sec theta, cosec theta, all that come from sine and cos. So we're gonna write everything in terms of sine and cos only. So I'm gonna replace the sec theta for 1 over cos theta. Right? So I'm gonna replace this for 1 over cos theta. And what am I gonna replace the tan theta for?
Sine theta over cos theta.
Right. Cool. Now in the denominator, You have two different fractions. So what we had to do, two different fractions,
Added
add it. Now, why we don't have to find LCM here?
because it's already in a fraction form.
No, that's not it.
Oh, both of them have cos on the bottom.
Exactly. They have the same denominator, so you don't have to find LCM. You can just add, right? Some of you okay so far?
Yeah.
Right. So I'm going to put 1 plus sine theta over cos theta. That makes sense?
Yep.
Right. Next thing I need to do, I need to write it in terms of division. So, Kira, this whole thing I have over here, that is the same thing as 1. What's sign going in the middle? 1 what?
Divided.
Right. This over here, that means division. So I'm going to write 1 divided by 1 plus sine theta over cos theta. Right. In the next line, what am I going to write? What do you think I'm going to write?
Um, would it be 1 over cos theta no, wait, no. It'll be 1 multiplied by cos theta, and then you flip it, so it'll be 1 plus sine on the bottom.
Yes. So we're going to put then. What is 1 by cos theta? What is 1 by 5?
No, I thought my mic was on mute, and I said the answer. I was like, cos theta.
Oh, yeah, yeah, it's cos theta. So you're going to put cos theta all over 1 plus sine theta. And truth be told, you can't really do anything. Like, if you look at this, you can't really do anything. And look what we're trying to prove. We're trying to prove 1 minus sine theta over cos theta. That kind of look like the opposite of this, and kind of look like the opposite.
Yeah.
So we had to do something. Something we had to do. You remember the example I shared with 1? Like 1 could be written as 3 over 3.
Yeah.
And if I multiply the top and the bottom by 2, is it still equal to 1 or is it equal to 2?
It's still equal to 1.
Right. So sometimes what you would have to do is you would have to multiply the top and the bottom by a new term. So if you look at this, if you look at what we're getting, you can't really do anything from this point onwards. But you know you have to get 1 minus sine theta on top. You see now, right? We had to get 1 minus sine theta on top. Look at what we're trying to prove. We're trying to prove that this is equal to this. So you have to get 1 minus sine theta on top somehow. So to do that, we're going to multiply the top and the bottom by 1 minus sine theta. And we will see how that goes. Kira, you understand?
Yeah.
See, me, how to get 1 minus sine theta. This is the only way you could get it. You have to introduce it. 1 plus sine theta by 1 minus sine theta is an example of what, Nicholas? It's an example of what? That's what B.
Complex.
Difference of two squares. So this over here will work out to be 1 minus sine squared theta. And we know from the main identity, here, finish all the main identity. Cos squared theta plus what is equal to what? What is the main identity you need to know? Cos squared theta plus what is equal to what is equal to 1.
Cos squared theta plus sine squared theta.
Right. And if I were to make cos squared theta the subject of the formula, that would be equal to what?
Um, 1 minus sine squared theta.
Right. So you understand why I replace the 1 minus sine squared theta for cos squared theta.
Yeah.
And I choose not to expand this just yet because watch, this cos theta here would cancel off with one of the cos thetas in the bottom, and that would leave us with 1 minus sine theta over cos theta. Definitely one of the harder questions. Definitely. But I think it's manageable, right? Um, I should have some more questions. I should. Oh yeah, this is also another really nice question. So I'll give all you this question for homework. Copy this question down. Part C. So prove the identity tan theta by sine theta all over 1 minus cos theta is equal to 1 over cos theta. Yeah, so Nicholas, copy on the question. This is also a very difficult question.
Um,
I wouldn't say as difficult as the last question though. One tier below. Yeah, so Kira, after looking at the recordings, you could try the question out. You try that question there. Prove the identity. Tan theta, sine theta, 1 minus cos theta is equal to 1 over cos theta. Yeah. All right. Nicholas, you have your question copied down?
yeah,
All right, nice. Kira, what about you? Have your question copied down?
Yeah.
All right. Well, thank you so much for coming to class today, guys. I will see some of you all Monday, Friday, and well, next Saturday. Yeah. Take care, everybody. Later.
yeah.
Bye.